Okay, hello, this is Max working on discussion 8 from spring 2015, CS61A. And this question is asking us to write a scheme function that when given an element, a list, and a position, inserts the element into the list at that position. Alright, okay. So first let's think about sort of what this actually is asking us to do, and we'll sort of draw things out in a box and pointer diagram. So if I call the function insert with, let's just say something like 3, and I give you the list 4, 5, 6, 7, and let's say I want to put this in at position 1, and we'll be consistent, right? We know that position 1 is actually the second element, so I want this to become the second element of this list. So how would this look? Well, so the list originally is defined to look something like this: 4 with a pointer to 5, with a pointer to 6, with a pointer to a list that has 7, and then nil. All right. So we're going to assume that this problem becomes very hard if we have to handle every possible case, right? So possible cases that might be weird are, say I get a position that's outside, that's longer than this list, then so say I get a position that's longer than list. The way we'll handle this is we'll just assume that doesn't happen, because else we need to handle it with a scheme error, and that's pretty much the only case that we'll have. And we'll assume we're not ever going to get negative positions. So we'll say that the position is somewhere in this list. And this would be explicitly defined for you on an exam. We would make it clear that the position was in the list or not, or that you have to handle errors. Okay, so what is this actually going to do? How should this behave when we run through it? Well, we know that in scheme we really only have access to the first element and the rest of the elements, but only sort of access to this element and this pointer. And so all that we can really do is we sort of just want to insert. So we kind of just want to do this, right? We want to add a link to this chain. So I want something that looks like this. And actually what I'm going to do is, this is also important in scheme. A lot of the times when we say this, insert an element into the list at that position, there's no really intuitive way to modify this list. And so what we're going to do instead, it's not like in Python where we can keep track of an object that has a pointer to keep track of an object that sort of has a first and a rest thing. So you don't have to worry about the intricacies of like dealing with links. What we're actually going to do is we're really just going to build a new list. And we're going to build a new list that looks like this up here. So I won't redraw it. But we'll leave our initial list intact. We're not going to actually modify that initial list. Okay, because we're just given this sort of list that we're passed in. All right, so let's think about it. Well, what happens if, so what are some base cases that we can deal with? Well, one base case I can think of is, if we're given something that's position 0, so say I get this and the position is actually, instead of position 1, I want you to put something in at position 0, then this becomes super easy, right? I just need to return 3 pointing to the rest of the list, right? So let's first handle that case. So if position is equal to 0, then I'm going to create a new list using cons that has my element as its first value, and then the list that I was passed in is the rest, right? So this is what's happening here. I'm creating a pointer to the rest of the list. Okay, so that's our base case handled. And now we can start working towards our base case. So how do we work towards our base case? Well, if I instead had this again as 1, this is exactly the same as creating a new list that has 4 as its first element, and then recursively calls insert on this smaller list and with a different position, right? So now we can actually, we only ever insert something into the list once it's at position 0. And so we can say, whoops, that doesn't make any sense. So if I get closer to position 0 by doing -1, then I'm saying this is equal to cons of 4, and and looks like this, cons of 4, and whatever inserting 3 as the first element of 5, 6, and 7 looks like, which in this case is going to be 3, pointing to a list that has 5, 6, and 7. All right, so we can sort of see this makes sense recursively. So let's think about how we can define that here. Well, we'll do cons, and instead of element, we'll put here car, because we're not going to insert. We want to keep track of this element in some way. This first element that we're not replacing, car of list with a recursive call to insert same element on the rest of the list. In this case, it would be 5, 6, 7, right? On the rest of the list, and now we can subtract 1 from position. And we got to make sure that all of this lines up. Position -1, insert. We'll finish off our cons here, finish off our if statement, and finish off our define, and we'll ignore that. Okay, so how does this look when we actually play it out? So if I say insert 3 into 5, 6, 7, I'm going to start with, at position 1, I'm going to start with 5, 6, and 7, and I'm going to say, well, I'm not yet at position 0, so I've created, I'll do this off to the side actually, I'll create 5, so I'll do cons 5 with a recursive call to insert 3 on 6 and 7 at position 0. And now this is going to be equal to cons 5, cons 3, and the list 6, 7, which we have up here, which looks like 5, 3, 6, 7, and then nil. Okay. Great. Okay, so if you have any questions about this, or there's anything confusing or unclear, please make a post on Piazza, and we'll get your questions answered. All right, thanks for watching.